All right, thank you guys. Thank you for the introduction. Actually, this is Colby Gaynor's talk, and I'll be giving it for him. He is not with us anymore. Fortunately for him, he got a job, so better to have a job than be here, I guess. So, anyways, I'll do my best to cover his stuff. So I felt it was kind of necessary. We just had Groundhog Day, right? And for us humans throughout civilization, we've done a lot to try to explain the natural world by using other living things, right? And so with the groundhog, we kind of infer about how long is winter going to be? Is winter going to end soon this year? Is it going to last really long? And so the groundhog sees its shadow, goes back into a long winter, right? But not all of those have to be like really weird ideas, like the canary in the coal mine, right? Coal miners used to take canaries down there to, make sure there wasn't too much gas in there that was going to kill the miners, because the canary would die before the humans. And then, of course, anglers, we always talk about, when the dogwoods bloom, X starts running, right? The white bass will start running. And so those are all seasonally tied in things that could mean something biologically, right? And of course, getting a little bit more sciencey, we use macroinvertebrates and other short-lived, fast-generating critters to kind of assess how we do with, habitat restoration or impacts, right? When we examine how macroinvertebrates are distributed among certain areas, we can infer a lot about the habitat. So that kind of leads me into the topic of my talk today. We'll be talking about population demographics of channel catfish in the upper Mississippi River. And to kind of start off, I want to talk about disturbance. And disturbance, of course, doesn't necessarily always have to be bad, right? But in the upper Mississippi River, disturbance really has come in the form of channelizations and dams and the loss of our floodplain connectivity. Additionally, we have a lot of agricultural runoff, and the big picture thing that we always talk about is climate change, right? But all of these disturbances and impacts to our natural environment ultimately are a result of we as humans and our need, right, for everything that we do in our daily lives. We need to be able to manipulate the environment. And so how can you quantify disturbance? Well, a really common way to do that would be to look at the vital rates. And so here what I mean by vital rates is recruitment, growth, and mortality, right? So recruitment is the number of individuals that are entering our population. Growth is the addition of gonadal or somatic tissue. And then mortality comes in two different flavors. It got cut off, sorry. Natural, and of course, it says fission, so fission mortality, right? But really, at the end of the day, fission mortality doesn't really have to just be fission mortality, right? And we'll talk a little bit more about this. So conceptually, we see that fish stock is fed by those two factors, and then it's taken out by mortality. So here we go, recruitment, growth, and mortality, right? And so managers for a long time have been incorporating these vital rates into yield per recruit modeling, right? And what we've done is we take exploitation rates and we can see that yield will increase up until a certain point, and then yield starts to decrease. And that's the basic, our conceptual model of how yield per recruit modeling works. And normally, as managers, we use this to evaluate harvest regulations, right? Minimum length limits, how much angling, fishing, right, pressure will do to our population. But on that flip side, going back to what I was talking about, two different flavors of mortality, right? You have natural, the one that the environment just will naturally take care of, things that die. But everything on the other side of that, at least in terms of mortality, just could be any additional type of mortality, right? And so in this instance, we could talk about environmental disturbance as that additive form of mortality. And what's cool, well, it's not cool, but the thing about environmental disturbance is that it's variable in intensity. And what I mean here is it's basically like who's punching you in the face, right? Is it Mike Tyson or is this little kid? And so when we think about that from a fish sense, it could be, is it just one crappie that died because of a bad, a spot in the lake with no oxygen and you just happen to be there? Or is it that is a system-wide effect and you're impacting 80, 90, 100% of your fish, right? So these varying levels of intensities. So with that, I want to talk about the canary in the coal mine and what we as scientists can use for the upper Mississippi River as a canary in the coal mine. And so channel catfish is kind of what we arrived at for this canary in the coal mine. And these three factors really are what kind of led us to pick channel catfish. Resiliency. So channel catfish are very known to tolerate a wide array of environmental conditions, right? A little bit hardier than most fishes. They can handle lower dissolved oxygen waters and higher temperatures. So we can kind of call these fish a hardy species. Further, when we look at the distribution of these fish, in its native range, it occupies a big part of the United States. And with introductions, I mean, they're pretty much in every corner of the country. And then when it comes to habitat, what our sampling has suggested that we've been able to find channel catfish in all types of habitat. So what I mean here is that for macro habitat features across all large-scale macro habitat features in our sampling locations, like impounded and backwater and main channels, we're finding channel catfish in all of these sites. Further, when we start looking at the smaller meso habitat features, we're still able to collect channel catfish at all of those different meso habitats as well. So what is our objective? We wanted to quantify channel catfish dynamic rate functions in the upper Mississippi River. Further, using those vital rates, develop this model that can show the sensitivity of channel catfish to varying levels of anthropogenic impacts or environmental perturbations, especially along some longitudinal gradient along the upper Mississippi River. Given that, we collected our fish in cooperation with the field staff at the long-term resources monitoring stations across the upper Mississippi River. In Minnesota, DNR, Pool 4, Lake City represents one of our sites. La Crosse, Wisconsin, with Wisconsin DNR. Bellevue, Iowa. Alton, Illinois. Cape Girardeau and Havana, Illinois on the Illinois River comprised the 6 sampling locations in our study. Fish were collected using a stratified random sampling implemented by the LTRM biologists from June 15 to October 31st. So this is a standardized sampling scheme. The gear we used to evaluate the vital rates were tandem hoop nets. So here we've got a small net and a large net set in tandem, and they're baited with soybean cakes. You can see the dimensions of the small and the large hoop net there as well. This map kind of covers the 6 different sites that we were sampling. And within those sites, all those red dots represent a specific individual net set, so sampling location. And so you can kind of see the spatial coverage that we're able to achieve there. Of course, fish were measured, total length, weight recorded, and the field staff also collected a bunch of other environmental variables as well. As far as aging goes, we followed Buckmeyer et al. 2002, Mount the Oto, sanded down. We took pictures of every otolith using a PAX cam. Otoliths were aged using 2 independent readers, and then if we had disagreements, they'd work it out. All right, let's get to the meat here. Well, overall, we collected 1,253 channel catfish. And they range from anywhere from 75 to 104 millimeters. Our ages range from 0 to 19, and our weights range from 10 to almost 54 or 100 grams. And so here I want to talk about, this is our length frequency. And here we see that some of the larger fish captured in our sample were all in these northernmost field stations. And then as we go further downriver, we see kind of less larger fish in our samples. And so here we have our catch curve residuals, right? And so the values generated, the recruitment coefficient of determination, generated from these graphs, gives us insight into how consistent or inconsistent your recruitment patterns are. And from our calculations, recruitment is more variable, so less consistent in the northern three field stations relative to the lower three field stations. Here we have our Bond-Vernalathy growth models. We see that, again, here kind of, going back to the our length frequency, we see that L infinity is larger generally in the northern field stations and smaller in the lower field stations as well. Here we have mortality or survival, right? And we see that mortality is lowest in the uppermost three field stations and then higher in the lower three field stations. All right, so the yield per recruit modeling. All right, here we see some take-homes from this. Very little bits of environmental perturbation have the potential to drop our yield, right? And so that's not a part of the curve we want to be in, at least as it relates to sustainability. We see that given the same amount of additional environmental perturbation, the field stations in the northernmost latitudes, these three bottom lines, have a relatively greater decrease in yield, percent yield, than in the lower three field stations. This kind of suggests that the upper three are really behaving more sensitively, right? That's kind of what this graph and the takeaway home, I think, is. So our data suggests that channel catfish in the upper Mississippi River are behaving differently throughout those 6 geographical locations. Further, larger individuals from the north field stations were collected, right? So in the north, we had larger individuals. Recruitment was less variable in those southern field stations. So recruitment was more variable in the north, right? So we got larger, more recruitment variability. Growth is variable across all field stations. And then mortality was lowest in the north and highest in the south. And then further, as we saw by taking those vital rates and throwing it into the model, the sensitivity models that we were able to develop suggested that, that percent yield decline per, this given environmental perturbation is a greater decrease in the upper three most field stations than the lower three field stations, suggesting more sensitivity in those upper three field stations than in the lower three field stations. So this information really, at the end of the day, serves as a baseline for managers, right? And we can kind of assess things that are happening to the upper Mississippi River through these vital rates. In the face of disturbances like rising water and temperature, high flow events, we all know, those of you on the river, last year was a really high flood event, right? Invasive species, all of these factors can change how our population behaves and our population dynamics, right? And at the end of the day, this baseline population characteristics are acting as environmental indicators, right? They can kind of be our canary in the coal mine for us too. Something bad is happening to these fish, something bad is happening to the upper Mississippi River. Our results suggest northern channel catfish populations are more sensitive to these environmental perturbations as well. And with that, I'd like to thank and acknowledge that this study was conducted by the U.S. Army Corps of Engineers, Upper Mississippi River Restoration Program, Long-Term Resources Monitoring Element. The LTR was a cooperative effort between the U.S. Army Corps of Engineers, U.S. Geological Survey, U.S. Fish and Wildlife Service, Illinois Natural History Survey, Iowa DNR, Minnesota DNR, Wisconsin DNR, and the Missouri Department of Conservation. And with that, I I'll take any questions.
You have some time for some questions.
Yes.
Can you provide a little more explanation on what the percent perturbation represents on the yield curve model?
Yeah, I can do that. So the question was, what does that percent perturbation mean? And so when we think about the class of yield per recruit modeling, it's taking into consideration our recruitment growth and mortality, right? And so at the end of the day, mortality is just two different things. And so we're, in the traditional modeling sense, we're considering, that bottom is that fishing effort, right? It's what we're taking out of the system to eat.
Representing the mortality rate.
Yeah, it could be anything, right? Yeah. I think that's the hardest part to grasp. But from this task, it's it can be anything. Yes.
Another question. I was just curious about, the amount of, or the level of commercial fishing harvest varies amongst those different areas too. How do you think that might impact?
Oh, surely that's got to have an impact. I know Colby has that data, and I don't know if anything came of that, but he does have that data, and that would be a really interesting, thing to look at as well. Yes.
So I study a much smaller system than what you were dealing with, but I kind of saw the same things as you move longitudinally downstream in our river. That the size structure changed significantly because we had mobile individuals that looked like they were swimming upstream of zones where they recruited young fish well, which ultimately is going to influence your catch curve because of frequency of cohorts and stuff like that. I was wondering if you thought that some of that might be due to fish movement or rapidly changing habitat as you go downstream.
Yeah, and I think, it could be, but I guess the underlying assumption at the end of the day for us is that immigration and immigration are equal, and that, we have to assume that, because if we don't, then that just, that's a whole different headache for us. So I think off of that, we're just going to assume immigration and immigration are constant, I think. I think that's the best answer I have right now, but yes.
Yeah, if you looked at any environmental variables that might be correlated with those variable recruitment in the upper river.
Oh yeah, for sure, and I think that's a great idea too, because we're talking about such a change of system from Lake City, Minnesota, all the way down to Cape Girardeau. If you guys aren't familiar, we're talking about a lake almost versus just a chute down there, right? And so the habitat changes, the nutrients, how they transfer is changing. Everything's behaving differently. So yeah, definitely those environmental variables could play a factor in that and be interesting to look at too. I'll get Colby on it. Thank you.
All right.
All right, thank you.
Thanks, Colby.